Hello, how's everybody doing? Yeah, get comfortable, please. There's no slide deck for this one. You just get to get really comfortable with my voice. So happy to see you all here. I loved your talk. It was awesome. You guys might have heard a little bit from me earlier, and my name is Brittany Zimmerman. I am a two-time analog astronaut, so I am you guys at different stages of your careers. And I want to talk about where you're at right now and how to get to maybe where I'm at if you're interested in taking that journey, and maybe a different journey too. Let's talk about some of that. First, do we have anybody from the inflatable lunar Martian habitat? Do we have UND in the house at all? Hello, UND. Woo! That's really where my space journey began. So for me, I was a mechanical and aerospace engineer. I designed aircraft for a long time until I got bored of that and decided I wanted to do the next best thing with NASA, and that was design habitats and spacecraft instead. So UND was really my avenue through that. So I got brought on to design a greenhouse module for the inflatable lunar Martian habitat that they have up in North Dakota. And I jumped at that. I was very excited about it, and I ended up being the first all-female crew member up there, which was very exciting. We also had our heat go out during this analog mission, so we turned all the cameras off for a while. That was exciting. Also then, I got kind of bitten by the bug, so to speak, so I decided to sign up for the Mars Desert Research Station. I had given a bunch of talks at a bunch of conferences about how to effectively design greenhouse modules, and that got, some notoriety and some attention, and I got asked by the SEDS group, which is a student group specifically for exploration and development of space, and we were asked to pull together a mission and lead that up at the Mars Desert Research Station. So anybody from MDRS? Yeah, there we go. Awesome. Yeah, so you guys may have heard that at some point in time they had a bit of a malfunction and they had some issues happen with their greenhouse module up there. So I actually was asked to come in to start rebuilding up that greenhouse module that they had, unfortunately lost. So I was the first crew up there to get that back up in action. So it was really fantastic. My space career progressed from there. My specialty in graduate work was in bioregenerative physiochemical hybrid life support systems for long duration space flight. Oh, lot to say, but what does it mean, right? For those of us in the ECLIS world, it means I'm responsible for all of the systems that keep people alive. You're very familiar with ECLIS. Yeah. And what that is any of the robotic type mission stuff, that's not really our specialty. But we're looking at air revitalization, right? Water reclamation, this is very important, nutrient cycle, radiation protection, pressure and thermal concerns. These are all really what keeps the human part of exploration, right, in check. And unfortunately, we are the dirtiest, messiest, hardest thing to do, in my opinion, in a lot of space missions. So it's a really fun job, but we also get to deal with all of the not so pretty stuff, right? Our waste that is generated is very important also. So I ended up inventing a technology. Anybody eating those brown cookies right now? Yeah, there she is. That takes astronauts' fecal matter, right? And extracts the water from the feces. So we can actually reconsume it. Yeah, ew. I'm the lady who makes astronauts, drink their own poop. Yay, big brownie points, right? Yeah. So not only that, we don't only recycle the water, I also then utilize the dried biomass that's left over from that system as filler and additive manufacturing processing. I've heard a lot of questions this weekend about 3D printing, so love to continue that conversation with those folks out there. But we can actually utilize that dried biomass as a filler for 3D printing. So what does that mean? That means on our long duration space flights, instead of launching a lot of voluminous and massive replaceable units for all of our mechanical systems, we can actually, only launch one or two of them And then we can 3D print all of the additional replacement units that we need, utilizing those materials that we're naturally making so that we don't have to jettison them out of our spacecraft. We can find useful things for this waste. So that was really exciting. Some of those technologies landed me as the youngest NASA principal investigator, and I leveraged the heck out of that. Yeah, to bring in lots of funding and lead different teams through the development of different technologies from TRL 0. So TRL is a technology readiness level. So that is how we gauge the maturity of different technologies. And a 0 is just an idea. It's something in your head, all the way up through 10. And 10 is a tried and true technology that's been commercialized for a long time, and we know what the long-term effects of even disposal of that on repeat is. So I was working on development of all of these different space technologies from TRL 0 and bringing it up through integration and commercialization. So I was fortunate enough to get to work on technologies that currently force astronauts to drink their own urine that is on the International Space Station as we speak. I developed some patents that were excitingly selected to land us on the moon here in 2025, and a bunch of habitats that are really slated for our first visits to the Martian surface. So a whole slew of stuff for the Department of Defense too, but that stuff will bore you guys to death, so we'll skip over it. But in 2019, 2020, I had a bit of a realization, or maybe an existential breakdown, perhaps. And for me, it was, why are we not utilizing a lot of these technologies that we have on spacecraft for terrestrial applications, right? Why are my host families that I'm visiting, right, when I'm traveling and backpacking through other countries, suffering from illnesses that are because they're, drinking contaminated water? I can get perfectly clean, potable drinking water to people in the dead vacuum of space. There's no excuse for not having access to this sort of water when you're right next to the source. And likewise, I was working on a program that wanted to bring about 1 million people to the Martian surface, right? What do we do for air revitalization? I had designed air revitalization systems that work for space suits, very small volumes, spacecraft, slightly larger volumes, and habitats for other planets. But what about when we're talking about colonization, right? The atmospheric composition of Mars is 95% carbon dioxide. That's a lot of greenhouse gases, right? If you're familiar with what's going on Earth right now, we're worried about 420 parts per million, right? Not even close to the same scale. So as we're looking at technologies that can deal with 95% carbon dioxide, why are we not having conversations with people in the sustainability and the climate space? Why are we barred from doing that in a lot of places? Well, I didn't think that was exactly the right way to go, and I wanted to be the person who could bridge the gap between what we're doing in the celestial life support realm and what I believe we need to be doing for terrestrial human betterment. And I decided to step away, and that was a really big ordeal then. I was working with and managing a group working on a project at NASA. I was working with a group at Boeing, 2 different university departments out of Texas, and 3 public-private partnerships. So my network was large. And luckily, I hopefully had done well enough in my position and with my networking that a lot of the people decided they wanted to join on this new effort and seeing how we can look at different types of technologies and different lessons learned from not only the space industry, but a lot of different sectors. And how could we apply that to the existential issues that we are all facing as humanity? Number one thing being climate change. We argued about that for a while because water is a big problem, food's a big problem. But the climate affects our water cycle. The water cycle affects our agriculture. So it all comes down to this pesky carbon, man, I'm telling ya. So we are now about, almost 200 graduate level experts from 50 different countries. And these are some really amazing people that have come together for the Yummy effort. Looks like Yummet, but it is Yummy, right? Something delicious to eat, it's Yummy. And what we've done is we've worked on climate technologies that can scale all the way up. Yeah. So not small little habitats, but giant all the way. How can we do this for all of humanity? We're not interested in the onesie-twosies. We've already done that, right? We're on our own analog mission right now on this planet, right? The space is outside, and our life support system is broken, you guys. We're screwing up our own life support system. I'll give you a clue. There's nothing else out there that's gonna keep us alive right now. We have to fix the life support system. So this is a really important problem that we have to band together and, and tackle. And that's exactly what this group has done. So get this. This is really exciting. Who here has heard of direct air capture technologies? Awesome. A lot of you. Who's heard of ocean capture technologies? Ooh, yeah, we got some blue solutions out there. What about waste to energy systems? Yeah, awesome. Very good. Yeah. Regenerative agriculture, anybody? Ooh, yeah, that one's got a lot of traction. Awesome. Well, one of the things that we've done is we took a system of systems approach. We've had a lot of talk here about systems engineering. What happens when you go even more system than that, right? Well, it turns out you don't get to play with the knobs of climate without affecting all the other knobs on the planet. You don't get to ignore those. So what do? Let's look at how we make them all interface together, right? It's the biggest systems engineering problem I've ever heard of. So we did that, and we came up with this beautiful technology that I'm really excited about, you guys. What it does is it brings in atmospheric air for the direct air capture folks. It brings in oceanic water for the ocean capture folks. And it brings in a lot of different waste feedstocks that are specialized to their specific areas and locations. So in different parts of the world, they have different types of waste that are produced, and this specifically hones in on those types of wastes. Now, some of our carbons and greenhouse gases are coming in as gases. Some of them are coming in the aqueous form. Some of them are coming in as solids. And depending on the matter that they come in at, or the state of matter that they come in as, and the quality of them, have they been exposed to pesticides, heavy chemicals, toxins of any sort, we do different things with them. And we came up with these technologies based on a lot of the stuff that we've learned in the space industries, which you guys are doing right now. That is the building blocks to all of these solutions worldwide. And now we get to take all of those things that we've broken down and turn them into, what do you turn them into? You get to pick. Well, we picked a sustainable building material as number one. Some of those dirty carbons. Building material industry right now is a humongous, and I mean humongous, polluter. If concrete market by itself were a country, it would be the third largest emitter of carbon dioxide in the entire world, behind only us here in the United States and China. That's how big of a polluter it is. So what if we could instead turn the carbon into a recyclable product that cures the planet instead of harms the planet in its production? Well, that's exactly what we've done. There's no mining, there's no calcination, and we store these for millennia. So we don't have to inject the carbons underground, which is a solution that a lot of people are leaning towards right now in the industry. Then what do we do with our higher grade carbons? It would be wrong of us to lock those higher grade carbons into concrete when they have really important nutrients in it that we need for our agriculture. So we grab those out specifically, and we produce something called biochar. Biochar is this really magical carbon. It's a solid carbon, and you can house a whole bunch of stuff in it. It has so many applications you wouldn't believe it. Never ask a soil expert what biochar can do, because you'll be sitting there for 200 years, all right? I'm telling you, this stuff is fantastic. But what it can actually do is it can regenerate all of the soils that we've monocropped to death, you guys. Agriculture is the only form, or one of the major forms of income for so many of the third world countries right now. You wouldn't believe it. And we've even pushed a lot of our monocropping practices onto these countries. And it is also our responsibility to fix these, not only in our own country, but all the way around the world. So we also produce green hydrogen and potable drinking water as byproducts. That's right, byproducts. We have a sustainable energy that's generated from this, and the thing that is the other existential crisis, which is water. And we can do this from the processing of that seawater that comes in. Now, you guys have all heard of desalination practices, right? Yeah, desal? Well, what happens when you do normal desal is it produces a brine material that gets pumped back into the ocean in most cases. And this is devastating our reefs around the world. This is a horrible solution, but people need the water, so they're forced to do this. This process produces potable drinking water from oceanic water with absolutely no brine production. There is no toxic chemicals we have to hide anywhere. We pull the salts out and we do something totally different with it and use it in the building of our materials. And now we have a water generation possibility for the entire globe. This is huge. The expanse and the implications of this are endless. So where does that lead us now? We have this. Cool solution. Is it scalable? Oh God, every engineer's least favorite question. Well, it is, right? We built the whole thing to be modular. It's so modular, in fact, that each one of our specific facilities can scale because we're pulling in carbons from all of the different points in the atmosphere, in the oceans, and in our feedstocks, that each of our facilities can do up to 1 billion, you guys, 1 billion tons of carbon dioxide annually. That means we need 42, everybody like that number? 42 facilities worldwide in order to be grabbing more carbon dioxide out of the environment than is released by all of humanity. Why is there no sounds? All of humanity, you guys. Isn't that insane? I mean, it's nuts, right? They say there's no single bullet, no silver bullet solution to this. Well, let's tell them that they're wrong, right? The silver bullet solution is all of the solutions put together into a symbiotic way that's circular. And we all knew it, right? We just needed to come together and bring the brains together that could actually execute that. And that's what we've done. We are entirely a volunteer-based group. This is 200 of the leading experts around the world who have come together for altruistic reasons, right? What kind of a foundation is that? It's the only kind of culture and foundation we would even want to exist in. We've got the inventor of Wi-Fi, the inventor of carbon nanotubes on the team. We have the godfather of biochar, Dr. Bruno Glosser. So science people who are in the soils, you're gonna love it. You know, we have the leading experts in the world out of NASA looking at electrolysis, hydrolysis, fuel cells, you name it, energy storage and renewables. And all of this to them is very exciting because our entire system is fueled by the waste that we bring in. So we bring in the garbage and it produces all of the electrical energy we need to fuel every single thing in our system. So we don't need the fossil fuels for those applications anymore, right? It's exciting news. So yeah, the team's come together, it's done all of this stuff, and now we're ready to build this at a larger scale. So we've decided to do it in Hawaii. Oh. You might think we chose it because it's a beautiful location, but it has other reasons for that. Hawaii is in a pretty bad place right now, right? Climate change is impacting them extremely hard, and the island nations around the world are some of the hardest hit by environmental things. So we're utilizing our own, island nation in order to make this a modular and repeatable facility that we can bring to all of the island nations, coastal solutions as well. So now, this is the exciting part, right? My journey started as what? An analog astronaut, right? You guys are analog astronauts or aspiring analog astronauts, or you were analog astronauts a long time ago. And all of the people on the team came from different industries. All of their research projects had almost nothing to do with climate change. Almost nothing to do with it. They were chemists looking at how things absorb onto them, right? They were looking at how soils interact with different microbes. They were looking at how to modify different things in different foods, right? And what to do with waste stuff. How do we recycle glass? How do we build a more efficient building material? It's the combination of all of these different brains, all of these different cultures, and all of these different ideas at the same time that leads to solutions like this. And climate will not be the only existential crisis that we face. It might be the biggest one right now, but it won't be the only one. So solutions like this need to be utilized as an analog for what we can do for any problem. It doesn't matter what that problem is. If you bring enough brains together, enough ideas, we will come up with the solutions for whatever it is. So don't lose so much sleep at night. Instead, give me a call, join Team Yame, would love to have you. We are right now, like I said, in 50 countries. I'd love to get us in every country, right? The more ideas and the more backgrounds, the better the solutions are. So regardless of what your approaches are, regardless of what your backgrounds are or how mature you are in your specific fields of interest and progressions right now, we would love to have you. If you want to talk about astronauts poop and pee, I'm here all day, I'm here tomorrow. If you want to talk about 3D printing, the climate, or anything in between, I'd love to meet every single one of you. So please don't be shy, and it's been my absolute pleasure to speak with you guys today. Thank you.